Actually seems quite obvious to us. Plant roots need water and oxygen at all times. Of course, they also get this in the soil. What's the problem? It's not quite so obvious, because if it doesn't rain for some weeks, water becomes scarce. And if the soil is flooded for a long time, oxygen becomes scarce. So how does this work in the soil? How can soil transport and store water and air? Via an extensive system of cavities that run through the soil, so-called soil pores. Ideally, these cavities are partly filled with water and partly with air. Immediately after rain, during flooding or in the groundwater area, they contain mainly water. In drought conditions, mainly air. However, flooding is not a problem, at least not in the short term. Oxygen also dissolves in water, and rainwater contains a lot of oxygen. Over time, the plants consume this oxygen. If the water does not drain away and fresh air flows in, oxygen becomes scarce. You see, soil is actually not as solid as you think. It consists of three different phases. It consists of a solid phase, the soil particles or aggregates, a liquid phase, the soil water, and a gaseous phase, the soil air. The soil pores are essential for many important properties of the soil. They determine how well a soil can absorb and drain rainwater, how well it can store water and release it to plants when needed, and how well it allows air to penetrate the pores. Which properties of the pores are important for this? What should the pores in an optimal soil look like? Soil pores have a very complex structure and arrangement. We will start by describing the simplest property, the diameter. The diameter is crucial because water is retained stronger by narrow pores than by wide ones. This is because water in the soil binds very well to many surfaces and it is difficult to detach from them. The narrower the pore, the more significant the surface effect, the capillary effect, becomes. A distinction is made between very wide pores up to 75 micrometers in diameter, narrow pores between 75 and 5 micrometers, and very fine pores with a diameter of less than 5 micrometers. Very wide pores, such as earthworm holes, for example, allow water to drain away very easily. Here, the effect of gravity is sufficient to remove the water. These pores are therefore only filled for a short time after rain. Narrow pores hold water in the soil even against gravity. They remain filled for days after rain, and the plant roots can help themselves. Very fine pores with a diameter of less than 5 micrometers remain filled even longer after rain, but they do not help the plants any further, because they hold their water so tightly that the plant roots cannot extract it from them. The number of pores with a medium diameter therefore determines how well a soil can store water for plants and how long water is still available for plants after rain. The number of wide pores, on the other hand, determines how well water can flow through a soil. This transport function of soil, however, is also affected by another properties of pores, by the extent of their mutual connections. Only a soil with many connections between individual pores can be well permeated by water and air. And what factors determine how the pore system of a soil is structured? As we shall see, many different ones. Firstly, the physics of soil, which we will discuss in the coming videos. What particles is the soil made up of, and how big are they? This essentially determines how large the spaces between these particles, the soil pores, are. The particles can form aggregates, and the soil pores naturally change as a result. Mechanical overloading of a soil leads to the formation of plate-shaped aggregates. These interrupt the pores leading downwards. Rainwater can only seep away poorly. Finally, chemical or biological processes can change the soil pores. Earthworms or dying main roots, for example, create wide, well-connected soil pores and thus facilitate the infiltration of water. To summarize, a soil that is ideal for supplying plants with water and oxygen has many wide pores that run through it. This allows excess water to drain away easily. It also has a large proportion of narrow pores, as this enables it to store water that is readily available to plants. Many different factors are affecting pore properties. We will learn about them more in later videos. In the next video in this playlist, however, I would first like to talk about a parameter that helps us to understand the movement of water in the soil, the water potential.